Welcome back, Chemistry 30. This is the second part to the 15.1 assignment. So I think we finished off with number 7. Here's number 8. Describe what is meant by solubility. So it is the maximum amount of solute capable of dissolving in a certain amount of solvent at a given temperature. Okay, so that's what that is. And if we look at in the textbook here, there's a page here that illustrates a graph of solubility versus temperature for various substances. So for example, if we look over here, we'll see that sodium chloride at 20 degrees C, and if we go across, that's around 36 or so, 36 grams of sodium chloride can be dissolved in 100 grams or 100 milliliters of water. And as you can see, the general trend here is that as temperature goes up, solubility goes up. There's one exception here with cesium-3 sulfate, but for the most part, these solids here, you can dissolve more as you increase temperature. Okay, crystallization. Dissolved solute forms an undissolved solute again, or solid. So it's the reverse process of solvation or dissolving. If you have a crystal on the bottom of a beaker of water, some of it goes into solution and some of it recrystallizes back. So it's the reverse processes. So we could kind of think of it like this: solvation and crystallization. So forming a solid again and dissolving. That's happening at the same time continuously, therefore it's called a dynamic equilibrium if it is a saturated solution. So here the next question involves comparing the rate of solvation and crystallization to unsaturated and saturated solutions. If something is unsaturated, the rate at which dissolving has happened must be bigger than the rate in which it's crystallizing back. That makes sense because you can continually dissolve solutes in an unsaturated solution. You're capable of dissolving more. Therefore, this rate must be bigger than the crystallization rate. And saturated solutions, ones that cannot hold any more solute, that rate must be equal. The rate at which the dissolving happens must be equal to the rate in which crystallization is occurring again, because the solution already contains the maximum amount of solute in that solvent at a particular temperature. So if you have a saturated solution and put more salt in it, let's just say, it looks like that salt is just sitting on the bottom of the beaker, but it's not. It's actually dissolving and crystallizing. It's just that our eye can't detect those changes that are happening. Therefore, it looks like it's just sitting there, even though it's not. Okay, so back to this. Unsaturated solutions contain less than the maximum amount of amount of solute in a solvent at a particular temperature, so you can dissolve more. And I mentioned this already, they are reverse processes. If you increase temp, you increase the solubility of a solid. Whereas if you look at a gas, where we could go back to here, the reasoning, particles are moving quicker, solid being pulling apart, increased temperature means increased kinetic energy and increased movement with molecules. So the ability to come in contact and pull each other apart. Gases are the exception to that rule. For example, higher temperatures cause more movement, which causes gases to be actually driven off from solution. So to dissolve more gas in a solvent, you have to actually lower the temperature. For example, keeping pop in the fridge ensures that that pop stays carbonated. So unsaturated contains less, saturated contains the maximum, supersaturated contains more than it should. And you may be asking, well, how in the world can that happen? So what you need to do is heat the solvent to a higher temperature and dissolve a lot more solute due to that increase in temperature. And then if you carefully lower the temperature, that solute will actually stay dissolved. If you're careful not to bump the solution or scratch the inside of the glass or drop something in it, it actually contains more solute than it should at that temperature due to heating it up and dissolving more. So this represents a picture of a supersaturated solution, and I'm going to do a demo here for part 3 of this booklet to actually show you it in action. So right here there's a little crystal. This is sodium acetate dissolved. It's a supersaturated. It contains more than it should. And once this crystal is dropped in, it provides a surface for that unstable solute to come and crystallize out until it looks like that. Really, really cool. Okay, so that is the booklet there. We'll go through some vocab terms now. So soluble, solute that can dissolve in a solvent. So I just use an example here of pouring sugar in a beaker of water and stirring it. Insoluble, the solute cannot dissolve in a solvent. So I use the example of oil and water. Oil is less dense than water. You can mix it, but it won't dissolve in it. It'll come out of solution like that. Solvation, the process by which solvent molecules surround the solute and break it apart. So we use the example of salt and water molecules pulling it apart. Solubility, that little graph that I mentioned earlier here, which demonstrates the maximum amount of solute that is capable of being dissolved in a certain amount of liquid. So I'm alluding to that graph there. At 20 degrees C, 36 grams of sodium chloride can be dissolved in 100 mils of water. So the maximum amount of solute capable of dissolving a certain amount of solution at a given temp. And then saturated, unsaturated, and supersaturated. Now, for example here, I just use that graph. Anything that's on that line illustrates the maximum amount of solute, so that is saturated. Any amount that's dissolved that's below that line is considered an unsaturated solution, and anything that contains more than it should, supersaturated. So it contains the maximum amount of solute in a certain volume of water at a certain temp. And of course, lastly, unsaturated, just see that previous diagram, a solution which contains less than the maximum amount of solute in a certain amount of solvent at a certain temp. And supersaturated, a solution which contains more than the maximum amount of solute in a certain amount of solvent at a certain temp. Kind of a mouthful there, but it makes sense when you think about it. Okay, and of course the process for this is heating it up, dissolving more, then gradually cooling it down. Okay, that's it. See you next time.